Hello friends, in this video I'd like to solve the following problem from William Lowell Putnam Mathematical Competition 1989, problem A2. Let a and b be positive numbers. We wish to evaluate the following double integral. One integral goes from 0 to a, second goes from 0 to b, and we are integrating e to the power maximum of b squared x squared, a squared y squared, dy dx. So my hints for this problem is not particularly hard. It looks daunting because of double integral, but you shall see it's not that hard. First of all, visualize the area of integration and check where in this area is, for example, b squared x squared greater than a squared y squared. And also remember that since our function is continuous, and the area of integration is compact, you may freely exchange the order of integration. That may be helpful at some point. So give this problem a try and I will see you in a minute. Okay, so I hope that you've managed to solve it. First of all, our integral, let's write it in the following way. Integral x goes, look, outer integral is over x. So x goes from 0 to a, and then inner integral is over y. So y goes from 0 to b, and we are integrating some function. dy dx. So it should be visible that our area of integration is a rectangle. It's a rectangle. Once again, turn it into a rectangle. Thank you. Okay, so our x goes from 0 to some number a, and y goes from 0 to some number b. Now, let's check when is b squared x squared greater than a squared y squared. We can safely take square root on both sides because we are dealing with positive numbers. And we see that it is equivalent to saying that y is less than b over a times x. Okay. What is this line? Notice that line where y equals b over a times x is exactly the line which includes the diagonal of our rectangle. Why is that? Because every line is uniquely established by two different points, and of course point 0, 0 satisfies our equation, and also point AB also satisfies it. And so now we know that here on this lower portion, here b squared x squared is greater than a squared y squared. Okay? And by symmetry, here the inequality will be reversed. Very well. So now our integral, our double integral, which goes over our rectangle of e to the power maximum of b squared x squared a squared y squared dy dx, we can split it in two integrals. First integral will be over the lower triangle, e to the power maximum of b squared x squared a squared y squared dy dx, and the second integral will be over the upper triangle. And maybe we notice that here if we are going over lower triangle, we know that b squared x squared is greater than a squared y squared, so here we have exactly that. And here, by contrast, we'll have a squared y squared. dy dx. Okay, and now let's write our integral in the following manner. First integral, the order of integration will stay the same. So first I will integrate over, outer integral will be over x. So notice that x, let's look at our picture. X goes freely from 0 to a. And then y, let's see, y also always starts from 0. Y always starts at 0 and ends on this diagonal. So y is from 0 to b over a times x. And we are integrating e to the power b squared x squared dy dx. While the second integral, here I will change the order of integration. Namely, I will first integrate, outer integral will be over y, inner integral will be over x. And let's see. Y goes from 0 to b. Why is that? Because we can start anywhere and y is visible that y is from 0 to b. And what about x? Well, if we have chosen some b, some y, let's say we have chosen this y on this height, on this altitude, we can do x then goes from 0 up to this point. X goes from 0 up to what point? Point on the diagonal. And if you remember, y is b over a times x, so x is a over b times y. And we are integrating e to the power a squared y squared. Very well. And now let's do the following. Notice that my inner integral is over y. And here I have a function only of x, so I can put this function in front of my integral. Here, very similar trick, we are integrating over x, so this is function of y, so I can put it before my integral. And that simplifies our problem a great deal, because now we have the following: e to the power b squared x squared, and look, here we have integral of 1. Integral of 1 is just the length of the interval of integration. This length is of course b over a times x dx. And here we have integral from y equals 0 to y equals b of e to the power a squared y squared. Again, the length of the interval of integration is a over b times y this time. Okay. And now let's do what exactly? Let's put our constants before integral. And here, let's do the same. Okay. And now let's do some kind of substitution. Namely, in the first integral, I will substitute u equals b squared x squared. Then du becomes 2b squared x dx, which means, of course, that x dx is du over 2b squared. And what about the bounds of integration? Well, x was from 0 to a, so u will be from 0 to a squared b squared. And for the second integral, I will substitute v to be a squared y squared. dv is 2a squared v y dy, which means that y dy is dv over 2a squared. What about the bounds? Y was from 0 to b, so v is from 0 a squared b squared. Okay. Nice. So our integral becomes the following. Integral from 0 to a squared b squared, b over a, e to the power of u, and instead of x dx, I can put du 2b squared. And second integral is a over b, integral from 0 to a squared b squared, e to the power of v, dv over 2a squared. And now let's simplify it. What can we do? Well, look, here we have a bunch of constants. We have b over a, here we have 2b squared. So that will be, you know what, I need a new page. I will need a new page. Okay. So I have the following, 1 over 2ab integral from 0 to a squared b squared e to the power of u du, and here I have exactly the same. Integral from 0 to a squared b squared e to the power of v dv. It's the same integral, so let's write it only once. 1 over ab integral from 0 to a squared b squared e to the power of u du, and it's a pretty elementary integral, because we know that we just have to evaluate e to the power of u from 0 to a squared b squared, and that's e to the power a squared b squared minus e to the power of 0, which is 1 over ab. And that is our answer. Our integral equals e to the power a squared b squared minus 1 over ab. Yeah, that's it. One more word before you go. It was crucial at some point, exactly at that point, to integrate in the right order. Because, for example, if you put first integral over y and then integral over x, you will end up with something like integral over something, x goes from somewhere to somewhere, of e to the power, for example, b squared x squared dx, and other integral will be over y. That type of integral is problematic because it is well known that there is no nice indefinite integral of e to the power x squared. In that types of situations, it might be beneficial to change the order of integration, as I did exactly, because then you can produce this type, so you can produce, for example, x, and then that type of integral, x times e to the power x squared, it is integrable. There is a nice indefinite integral of this function. So yes, try if you encounter some types of problems, try to change the order of integration, and that sometimes does the trick. Thank you for watching, and I will see you soon. Goodbye.